Hi everyone, we're going to continue with our tangent line properties. Okay, in this problem, this is our picture we're going to be using, and the directions say that CB equals 10, which remember, in geometry, it's really helpful if you label your picture. So I'm going to label my picture. So C to the B is 10 units, and A to the B is 6 units. Okay, and we want to find what DC is. So eventually, this is what we're looking for. So I'm going to call this X because we don't know what that is. So that says X, even though it's really hard to see. All right, so looking at my picture, I know A to the B is a radius. Do you spot another radius in the picture? Oh man, segment A to the D is also a radius, which remember you guys, every single radius length is the same measure. So AB is 6, which also means that AD is also 6. So I know that that part is 6, but I want to know what this part is outside the circle. Okay, now, we're going to have to use one of the tangent properties that we discussed in the Prezi. So I'm going to go back to the Prezi to recap that real quickly. Okay, so there's a property that says that if a line is tangent to a circle, then the radius is perpendicular to the point of tangency. So if a radius touches a point of tangency, they will be perpendicular. The tangent line and the radius will be perpendicular, which means a nifty 90-degree angle will form. So let's go back to our picture and see if that will help us. Okay, so I have this tangent line right here. Point B is my point of tangency, and guess what, you guys? Segment AB is a radius, so that means the radius and the tangent line must be perpendicular, which what does that mean? Angle A to the B to the C is. It is a right angle. You guys are so brilliant. So if you guys see now this triangle that I'm dealing with, since the triangle is a right angle, it is a right triangle. Okay, and I'm trying to find the side lengths of a right triangle. What nifty theorem do we use to find the side lengths of a right triangle? Correcto mundo. We do use the Pythagorean theorem. So I'm going to use the Pythagorean theorem to help me to find x. So let's see what happens. So the Pythagorean theorem is a squared plus b squared equals c squared. Okay, so to remember, the a and the b are the sides of the right angle, which you can assign either side of the right angle to be a or b. So I'm just going to assign this one to be a and this one to be b. The side across from your 90-degree angle is the C value. So this is the segment across from my 90-degree angle. So this whole thing, A to the C, is going to be my C. All right, let's get this thing set up. So A squared is going to be 10 squared. So I'm going to fill that in. So 10 squared plus B squared, my B is 6, so C squared equals, 6 squared equals, and it doesn't matter, you could put the 10 in the parentheses with the squared, or you could put the squared outside. It doesn't matter. I don't even know why I put them in a parentheses. Honestly, it's irking me, so I'm going to just ignore me. I'm having a moment, you guys. Okay, so let's try this again. So A is 10 squared plus B, which is 6 squared. You don't really need the parentheses. Equals C squared, which C is the length of this whole piece. What is the length of the entire A to the C? It is this piece plus that piece. So it's going to be 6 plus x. So C is actually going to be 6 plus x quantity squared. And I am going to put that one in a parenthesis because that one's going to be more helpful. Okay, so let's start simplifying some things down. So 10 squared, 10 times 10 is going to give me 100. So 100 plus 6 times 6 is 36 equals, now don't forget you guys, 6 plus x quantity squared does not mean you square the 6 and the x. That's when the demon cats get you, so watch yourself. Okay, so we're going to be writing this as 6 plus x times 6 plus x. Okay, and remember we have to distribute when we have two parentheses side by side. So I'm going to need to distribute. All right, so before I do that, I'm going to start combining some like terms. So the 100 and the 36 will give me 136 equals, let's start distributing. All right, so I'm going to start with the 6 and multiply to each piece. Then move on to the x and multiply to each piece. So let's start with our 6. So 6 times 6 is 36. 6 times x gives me a 6x. All right, and I'm going to do the same thing with my other term in my binomial. So I'm going to do x times 6, which is 6x. And then x times x, which gives me an x squared. All right, guys, let's keep on going. So now I'm going to combine my like terms on this side. Okay, which my only like terms that I see are these two. So I'm going to combine these two right here. Bam. All right, so I'm going to bring down my 136. So we have 136 equals 36 plus 6x plus 6x will give me a 12x. So 12x and then plus x squared. All right, I'm going to zoom in a little bit so you guys can see better. All right, guys, so our goal is to find x. We're trying to find x, this piece. We're trying to find DC, which is technically what we have labeled as x right now. Okay, so currently I have a quadratic and I have more than one term, which means the way that we solve for x when we have 3 terms is either to do the quadratic formula or factor, but don't forget, what does this side of your equation have to equal before you can factor or use the quadratic formula? This side has to be 0, so I need to move 136 to the other side. Guys, and I'm actually going to like rotate this equation around because I like my x to come first. So I'm going to rewrite this with x first, but I'm also going to move this over. So let's go ahead and move this over. So how do I move positive 136 to the other side? I would subtract it on both sides. Nice. Okay, I'm going to subtract it to its like term over here. Which one of these terms is the like term to 136? It is 36, so I'm going to subtract it from 36. Okay, so 136 minus 136 cancels and turns to 0, and 36 minus 136 is negative 100. Okay, so now I'm going to rotate this around. And don't forget, it's always helpful to write your equation in standard form, which means you start with the highest exponent and go down to the lowest one. So my highest exponent is x squared, so I'm going to write x squared. My next highest exponent term is the 12x, so plus 12x. And then minus 100 equals 0. So I just have flipped the equation around using the symmetric property. Alright, so in my opinion, it's always fastest to try to factor. Okay, so I'm just going to do a quick brainstorm. If I'm going to factor this, I need to find 2 numbers that will both multiply to be a times c, which secretly there's a 1 here. So 1 times negative 100 is negative 100. So I want to find 2 numbers that multiply to be negative 100 and add to be 12, which is our b term. So, let's think. Are there any numbers that multiply to be 100 and add to be 12? Gee willikers, there are not any numbers that do that. So what do we have to use if we cannot factor? We do have to use the quadratic formula. So I'm going to be using the quadratic formula to solve this. And I'm going to bring this up here to help me solve. So I'm going to bring this bad boy up here. Alrighty, so we're going to use our quadratic formula, which the first thing to do is to identify the a, b, and c, because that's going to help us. So the a is 1, the number in front of x squared. The b is in front of x, which is 12. And the c is the number without the x, which is negative 100. Alright, which I know you're already humming the song. Opposite of b, plus or minus the square root of b squared minus 4ac divided by 2a divided by 2a. So, I know you had a great time reliving that song. I'm going to write it up here just so we don't forget the quadratic formula. Alright, let's do this thing. So, x equals the opposite of b, so the opposite of positive 12 is negative 12. Plus or minus the square root of b squared, so 12 squared, minus 4 times my A, which is 1, times my C, which is negative 100, which I didn't leave much space, so I apologize. So that's a 100. Sorry, guys. All over, so all over 2 times A, which is 1. All right, let's start simplifying this thing down. I'm going to zoom in over here so we can see this a little better. Sorry, it's blurry, you guys. Okay, so let's keep going. So I have x equals negative 12 plus or minus the square root of 12 squared. 12 times 12 is 144. Okay, and then I'm going to multiply all this together. Don't forget the negative sign is attached to my 4. So this is like negative 4 times 1 times negative 100. So negative 4 times 1 is negative 4. And negative 4 times negative 100 is positive 400. Holy hot dog. It's going to get to be a big number. All right, all over 2 times 1, which is 2. All righty, let's keep on going. So x equals negative 12 plus or minus the square root of 144 plus 400, which is 544. All over 2. All right, you guys, so in order to simplify this further, okay, we have to reduce down this radical, which 544, I'm going to tell you right now, it's not a perfect square. So how do we simplify radicals that are not a perfect square? We do have to do a factor tree. Okay, so I'm going to do the factor tree over here because I'm kind of running out of space. Okay, so I'm going to simplify the square root over here. Okay, so let's see here. So we got 544. Let's see if we might not even have enough room over here. Let's see. Okay, so 544. All right, let's see what we can do. I should have wrote that higher up. Jeez, Miss Long. I'm not making good decisions today when I make this video. So 544. All right, let's break it down. All right, so what are some things that go into 544? Well, there's lots. I'm just going to go with, let's see here, 4, and 4 goes into 5 one time, remainder 171, I want to say. Let me just double check my math. 4 times, let's see here, 1, remainder 1. Oh, I'm sorry, that's not a 7. That's not a 7. That's not a 7. 4 goes into 14 3 times. Sorry, guys. Again, I'm not doing good today. The demon cats are getting me bad today. Alright, so let's do this again. 4 goes into 5 one time, remainder 1, then 3, remainder 2, 6. Okay, I'm going to say 136. Let me check my math again. So 4, carry the 2, 6, 12, 13, 14. Yes. Okay, and since the demon cats have got me, I'm just going to do it out because I just don't trust myself today. Yes. Okay, so I'm good, you guys. Sorry. Okay, let's keep going. So 4 breaks down into 2 and 2. 136 breaks down into 2, and let's see, 68, I want to say. So 2 times, yep. Let's keep going. 68 breaks down into, let's see here, so 2 and 34. And 34 breaks down into 2 and 17. Okay, so now let's start circling our cute little couples, which I'm just going to double check everything to make sure I'm good. Yes, okay, we're good, we're good. All right, so now remember, you guys, when we do our square root, okay, we have to circle our cute little couples, okay, which I'm going to be kind of doing this on both sides. Well, I can do it over here, actually. All right, so I'm going to have my square root ready. So remember, we're circling numbers at the ends of the branches. So if it breaks down, they don't count. So like the 4 broke down, so I don't care about it. And that marker doesn't work. Okay, the 136 broke down, so I don't care about it. The 68 broke down, so I don't care about that. And the 34 broke down. So we're looking at all of these numbers right here. Alright, so let's see if we find any cute little couples that will leave the house to go on their hot math date. Let's see. Well, I have one pair of 2s right here, so one will hop out. Remember, for each pair, only one hops out. Okay, I have another pair of 2's right here, which means another 2 will hop out. And for every number that hops out, you multiply them together. All right, and then these 2 are my lonely single numbers, so they will not be going on their hot math date, which means they will stay inside the radical. So I'm going to do 2 times 17 inside of my radical. All right, let's keep going, you guys. So this will be, if I multiply this out, this will be 4 root 34. Okay, so that's what I'm now going to be replacing my square root with. So everything else will be the same except for my square root. All right, so I'm going to zoom out so we can see that real quickly. So now I have x equals negative 12 plus or minus my square root that is simplified down to 4 root 34 all over 2. All right, guys, and my last step is to simplify all the numbers down that I'm able to. Okay, so let's see what makes sense. So remember, you can simplify the numbers down that are in front of the radical. So these are my 3 numbers that I'm allowed to simplify. You cannot simplify the square root down. You can't simplify numbers inside of a square root that are not inside of a square root. So be careful. So is there a number that will divide into 12, 4, and 2? It is going to be a 2. So this is going to be x equals negative 12 divided by 2 is negative 6 plus or minus 4 divided by 2 is 2. So 2 root 34. Remember, don't forget, don't simplify down that 34. Don't touch the radical. And then 2 divided by 2 is 1. So I could say over 1. But anything divided by itself is just itself. Or anything divided by 1 is just itself. So I'm not going to put it over 1. Guys, and then the last step, we need to figure out which answer makes sense. Because remember, when you're simplifying, or when you're doing the quadratic formula, you have a plus or minus, which means there's 2 answers. Okay, so we're trying to find a length of a triangle. Which numbers do not make sense for a length? Positive or negatives? Negatives do not make sense. So currently I have a negative 6 plus 2 root 34, okay, which root 34, if we think about that, so the square root of 36 is 6, so it's almost 6. This is like negative 6 plus 2 times 6, which is like 12. So that should give me a positive number. Let's see if I do negative 6 minus another number. So if I do negative 6 minus 12, is that going to give me a positive number? No. Guys, so I'm not going to include the negative because I cannot have a negative side length. So guess what, you guys? X is going to be just negative 6 plus 2 root 34. And guess what, you guys? That problem will be done, so. Wasn't that exciting? There's a lot going on. But the more exciting, or the longer the problem is, the more exciting it is. So, yeah. So this is going to be x equals negative 6 plus 2 root 34. And bam, that's what that length of that side of the triangle is. So to remember, you guys, this is approximately 12. It's a little bit smaller than 12 because the square root of 36 is 6. So it's going to be like negative 6 plus 12, which is like around 6-ish. So that piece right there is approximately 6. So it's a little bit under 6, but yeah. All right, guys, that's it. Wasn't that fun? I know, I agree. Like normal, we agree on most things. Awesome job, you guys.